We'll be starting Jan 17 today. Let's start with question 1. Let's see what the question says. Which of the following expresses the joule in base units? There are several ways of answering this. Let's identify what joule stands for. Joule is the unit for energy, and a body gains or loses energy when work is done on it. And what is the equation for work done? The equation for work done is force times displacement. Now let's break this down. Force, what is the unit of force? And it has to be in base. The unit of force is Newton, but when it comes to base, it's kg, meter per second squared. And the unit for displacement is meter. Then the final unit would be kg, meter squared per second squared. Kg, meter squared per second squared. So my answer would be D. Please take a look at this, everyone. This is the way you have to solve questions like this. Let's move on to number 2. Select the graph that correctly shows the variation of an object's kinetic energy with its velocity v. Again, if you recall the equation, what is the equation for kinetic energy? It's half mv squared. Wait a second. Half is a constant, m is also a constant. So this equation is in the form of y is proportional to x squared. If you have a graph of y against x squared, the equation is y against x squared, or y equals or y proportional to x squared, and you are asked to draw a graph of y against x. What is the shape? It cannot be for sure a straight line because there is a square involved. Had there not been the square, or if you are asked to draw a graph of, please check this out, y against x squared, then it would have been a straight line to the origin. You are treating x squared as a whole quantity. But in this equation, kinetic energy is proportional to v squared. That's true. So if you are asked to draw a graph of kinetic energy against v squared, then the graph would have been straight line to the origin because kinetic energy is proportional to v squared, but you are not asked to draw a graph for v squared. You are asked to identify the graph for v. Then kinetic energy is not proportional to v. So what should be the relationship? This, and now you know why the curve, because there is a square involved, and it's in the form of y proportional to x squared. And if we're asked to draw a graph of y against x for the equation or the expression y is proportional to x squared, the graph would have been like parabolic. So my answer is D. For 3, we have a block of mass m is placed on a bench and the horizontal force F is applied to the block. The block accelerates along the bench, travels a distance d in time t, and reaches a velocity v. The work done by the force F on the block is, okay, they asked us to find out the work done. This is actually one of the simplest things ever. We know work done is always equal to force times displacement, and this time they gave the distance, so it's the same thing. It should be force times distance, FD. Pretty straightforward. Answer should be A. To travel from position A to B, a car travels 20 km due east and then 20 km due south. Okay. Select the row from the table that correctly expresses the magnitude of the total distance and the total displacement. Okay, what is the difference between distance and displacement? We know this from our IGCSEs. Distance is the path length of the total distance traveled, right? So distance is the total path length, whereas displacement is the shortest distance between 2 points. And we all know shortest distance between 2 points is always a straight line. Now, The blue line basically represents my displacement, and you can clearly see that this makes a right angle triangle, and this is the hypotenuse of this right angle triangle. And what is the hypotenuse of a right angle triangle? Let's call this S. So S squared should be 20 squared plus 20 squared. So S should be root over 20 squared plus 20 squared. So this is my displacement. But as I've been saying, distance is the total path length. So 20 is one of the path, and the other 20 is also the other path. So the total path length would be 20 plus 20, that is 40. So my distance is 40 and my displacement would be this. Let's choose distance is 40, displacement is root over 20 squared plus 20 squared. My answer should be C. Let's see for question 5 and 6. Both of these are completely related to unit 3. Two groups of students were asked to perform an experiment to determine the acceleration of free fall. Each group repeated their experiment 3 times to check their result. In each experiment, a steel ball fell through a height of just under 1 meter, and the time for the ball to fall was measured. Group 1 used a stopwatch to measure the time. Group 2 used light gates connected to data logger to measure the time. For both groups 1 and 2, they used 2 different methods. The students measured the height the ball fell using a meter rule. The height should be recorded as, okay, so if you look very closely, you'd see all of these, comes down to the same value. 85 centimeter, 0.85 meter, 0.850, 8.5 times 10 to the power minus 1. All of these actually are equivalent values, but the only difference between all of these values is the significant figures. So also the units are also different. Some of them are given in centimeter and others are in meter. How do I answer questions like this? The rule of thumb would be the measuring device that you're using. Let's say a meter rule. So intrinsically, if I ask you what is the scale of the meter rule, you'd see it's 100 centimeter. Right? The entire length of a meter rule is 100 centimeter because 100 centimeter makes 1 meter. So 100, how many SF is there? So in a meter rule, how many significant figures? It's 3 significant figures. So my answer should be in 3 significant figures irrespective of the unit. And if you look at the mark scheme or the examiner report, you'd see the exact words over there as well. So a meter rule can measure to 3 significant figures. So my answer must also be to 3 significant figure. That is irrespective, I repeat, of the unit. Let's see which of these values is given to 3 significant figure. This is 2 SF. This is also 2 SF. This is 1 SF because times 10 to the power doesn't have any SF. So this is 2 SF. Only this value is in 3 SF. So my answer has to be C. Number 6. Okay. Again, I've been saying that this question is 100% related to unit 3 as in the practicals. So reliability and validity, we haven't discussed this yet, but if I ask you, what do you think these 2 terms could represent? Reliability as in, if you repeat the experiment over and over again, if you get the same values after successive repetitions, you say that your value is reliable. And validity has nothing to do with reliability. A value can be valid without being reliable. Valid as in, if your answer is not too far-fetched and if the measurements that you're making is, linked is not the best word, is close to the actual value, then it's valid. As long as it's not incorrect, it's a valid measurement. But reliability means if you yield the same value for every repetition, then your measurements are reliable. So check this out. Group 1 uses a stopwatch to measure the time. The moment you use a stopwatch, you can use a stopwatch very accurately, but there will always be some random errors due to your reaction time. Reaction time is not in your hands. So reaction time would cause the value to fluctuate a little bit. So when the value fluctuates even a little bit, so when you round it off to, let's say, 1 SF or 2 SF, it's going to be the same, but the third SF may vary. This is what I'm saying, everyone. Please check this out. If you take, let's say, 3 values for stopwatch, 0.51, 0.52, 0.53. And if you find out the average, you'd see the average or the mean would be 0.52. And what if the actual value is also 0.52? So is this result not valid? Of course it is. As long as it's close to the real value, it is a valid measurement. But is it very reliable? No, because the value keeps on fluctuating. So if you are performing the experiment in the correct method, you'd see that using a stopwatch will give you a valid result. That's fine, but it won't give you a reliable result because the values will keep on varying. Now, group 1, it is not the most reliable result, but it can be valid. Not reliable, valid. But group 2, once you are using data logger and light gates, of course it's valid if the method is right, and it's also very reliable because you can cut out the human reaction time or human errors. So it's both reliable and valid at the same time, but for group 2 it's valid but not reliable. My answer should be C. Number 7 is really important. Everyone, please read the question yourself. Okay, so what does the question say? An object of volume is given. My suggestion is always mark the relevant keywords, the numerical values that are given, because most likely you'll have to use these. This is the volume. Highlight the volume part. And the density of the fluid in which the object is immersed is also given. And this is actually water. 1000 kg per meter cube is the density of water. The reading on the spring balance, okay. Contrary to what? Increase or decrease? Compared to what? Let's check this out. Let's say if you have a balance like this, there is no water and you just hang a piece of stone from this balance. You just hang a piece of stone from this balance. So what are the forces acting on this balance? Of course, there is the weight of the stone and the tension has to balance the weight. So if I ask you, what are the forces acting on the stone? I should have asked, what are the forces acting on the stone? These are the two forces. One is weight, other one is tension. Now let's bring the same thing into a container. These two forces are still going to be there. Weight is there, tension is also there. But now there will be a third force. Guess what that force is? Once you immerse something in a fluid, because you are displacing a certain volume of fluid, there will be an upward force on you, and that's what we call the upthrust. Now, along with tension, there will be an upthrust as well. Okay, so this tension is basically the reading. The tension gives you the reading. Over here, when there was no water involved, no fluid involved, this tension was directly equal to the weight. But look at this, everyone. Tension plus upthrust will give me the weight, and I could equate them because it's still stationary. The forces are still balanced. Now the tension is weight minus upthrust. So this was the initial reading, but now from the initial reading, the reading would decrease by how much? Decrease by the upthrust, amount of upthrust. And we all know the equation for upthrust. Upthrust equals rho v g. For upthrust, rho is always the density of the fluid. What is the density of the fluid? 1000. V is always the volume of the object, as in 2.4 times 10 to the power minus 5. And finally, G is, we know, 10. So 2.4 times 1000 times 9.81. So I have two possible leads between B and D. But check this out. If you look at the equation, it's a subtraction, meaning it cannot increase. It has to decrease by this amount. So upthrust decreases by this amount. The answer for 7 should be B. Let's move on to 8. Eight is linked to moments. A uniform rod is found to balance when a pivot is placed at the midpoint O as shown. The rod is replaced with one made from two different materials. The right hand half of the new rod has double the density. Okay, this is where you have to start marking. Let's check this out. The right hand half of the new rod. They're talking about this part. Right hand half of the new rod has double the density and half the diameter. Length is the same, density doubled, and diameter is halved. Okay, now we have to find out what happens to the mass. We all know mass. I mean, if you start from the density part, density is equal to mass by volume. So mass would be density times volume. But the volume is not directly given. Volume is given in terms of diameter. So when you have half the diameter, let's see what happens. Mass equals density times, okay, so look at the shape of the rod. It's cylinder. What is the equation for the volume of a cylinder? It's pi r square times L. So the length is the same, but the radius is different now. The diameter is halved, so it should be so radius is equal to diameter by 2. It's d square by 4 because r is equal to d by 2 and r square should be d by 2 whole squared. D by 2 whole squared is d square by 4 times L. Now let's work our way. If you have double the density, density is doubled and diameter is halved. You see, if you have this diameter, half squared is 1 by 4. So you increase this by 2 times, but you decrease this by 4 times. So what does this have on the overall effect? On mass. So the mass decreases by 2 times. Since the mass decreases by 2 times, this part has a smaller mass than this part. So the idea is when you place a pivot and the object on the pivot, it has to be, if it has to be balanced, there has to be equal mass on both sides. Mass over here has to be equal to the mass over here on both sides of the pivot. So if you place the pivot here, you can clearly see that this part has a smaller mass. So where should you place the pivot? You have to place the pivot to the left of O. My answer should be B. Let's move on to the next one. That is number 9. Concrete is used in both the spans and the supporting columns in a bridge. The spans need to be reinforced with steel, but the supporting columns do not. Please look at this. These are the spans and these are the column. Now, the question says the spans needs to be reinforced. What does the term reinforce mean? Reinforce means to make something stronger. So when it comes to the spans, you need to make the spans stronger with steel, but the supporting columns do not need to be made stronger. Now you have to understand and acknowledge the type of forces that the spans and the supporting columns are having to endure. Look at it this way. When, let's say, a very heavy truck travels, let me draw a really heavy truck. Or a lorry. Really large and heavy lorry is traveling on this bridge, carrying, lots of goods. Now, what is this truck trying to do? This is pressing down on this surface. So the bridge will bend a little bit like this. Think of this as a string attached at two fixed positions, and a person is, moving along this string. What will happen? Will it stay taut like this? Of course it's going to stay taut, but is it going to stay horizontal like this? Of course not. It will bend a little bit like this, as in stretch. The proper word should be stretch. And when something stretches, it is under tension. So when a bus or a truck or a lorry travels on the bridge is under tension, and that's why it has to be reinforced. What does this mean? That concrete, when does it have to be, when is it necessary to reinforce? When it is under tension. But look at the columns now, guys. There is no tension in the column. The columns are being compressed. This lorry is trying to compress these columns, meaning the columns are enduring a force called compression. And the fact that they don't need reinforcement means they're really strong under compression. But the spans undergo tension. And since they have to be reinforced, this means that it's not very strong under tension. Now you look for the answer. It's strong under both tension and compression. It's not strong under tension and weak under compression, just the opposite thing. It's weak under both. No, it's not weak under compression. It's quite strong under compression because you don't need the steel. You don't need to reinforce it with steel when it's compressed. It's weak under tension and strong under compression. Yes. Why is this the case? Because the spans have to be reinforced and the spans undergo tension. So the answer for 9 would be D. It's weak under tension and strong under compression. Moving on to number 10. Look at this. A 1.8 kg mass is suspended from the end of a spring of original length 0.040. The spring extends and is now 3 times its original length. Okay, so these type of questions are a bit confusing because a lot of times students fail to visualize what's going on here. So it says initially the length was L. Now it's 3 times this L. It's 3 times this L. Now if I ask you, what is the extension? Extension is always new length minus original length. So del L or the extension is 3L minus L, as in twice L. And what is the question? The work done. Work done is always force times displacement. And what is the displacement? This twice L is the displacement because this twice L distance is moved by this force when you attach it. So what is the force? It's the weight of 1.8 kg mass. So it's 1.8 times 9.81 times twice L, and L is 0.04. What is the answer? It's 1.4 joule. But wait a second. You are dealing with a spring here. When it comes to a spring, let's just recall the graph for a spring. It's Fx. And the shape of the graph is a straight line through the origin. And we all know the area under the force extension graph gives the work done. This is actually again one of the most common mistakes the students make. So the moment they see work done, they directly jump to force times displacement, but you are not dealing with any random work done. You are dealing with the work done on a spring. And when it comes to a spring, work done is always half Fx. So this value has to be divided by 2. So what is the value? 0.7 something, 0.71 joule.